Alright guys, welcome. As I said, I would record myself doing some of the work here with zero and negative exponents, so uh, this is it. For those of you who are still a little bit confused by it all, that's perfectly okay. This will hopefully maybe clear a little bit up. So remember, when we have zero exponents, so that's b to the 0th power, that will always equal 1 as long as b does not equal 0. So obviously if b was equal 0, then your answer would be 0, because 0 times whatever is 0, like 0 is 0. However, if you had like 4 to the 0 power, that's going to equal 1. Or and so on. It doesn't matter. What else? Negative exponents. So if you had b to the negative nth power, that's going to equal 1 over b to the n. So when you have this negative, you're gonna take the reciprocal of it, right? So you're gonna flip it over itself. So let's just take a look at this one here. Which of the following is not equivalent to 5 to the negative 2nd power? Well, we know that's because it's a negative exponent, we're gonna flip it over. So we should write it as 5 to the 2nd power. Okay, so that means that 1 is equivalent. So I'm going to cross that one out. Now, if we wanted to simplify this further, we would square out 5. So then it would become 1 over 25. Well, that's 3, so let's cross that one out. Now, 1 over 25 is definitely not 1 over 10. And just to verify, if we were to change this into a decimal, it would be 0.04. Think about it. 1 over 25, you could multiply this by 4 to get to 100. So it's equal to x over 100. Here we're multiplying by 4, so we're going to multiply by 4 here, and that gives us 4 over 100, which is equal to 0.04. So therefore 0.04 is equivalent. So remember, this is a big thing. Make sure you are fully reading the question, because this one is asking which of the following is not equivalent. Alright, if f of x, and f of x is just a way to write out an expression. It's the same as saying like y is equal to or whatever, but it's just writing out an expression. So if f of x is equal to 3x to the negative 2nd plus 2x to the 0, then which of the following is the value of f of 2? So when you see this, which of the following is f of 2, all that means is that you are going to plug 2 in for every time you see x. So this is the same thing as saying x is equal to 2. Alright, so let's rewrite this whole expression so it's in its simplest form. Alright, first we're going to take this 3x to the negative 2nd. Remember, this exponent is only tied to the x. So then it becomes 3 over x squared plus, and then because this is x to the 0, we could replace that with a 1, so it's going to be plus 2 times 1. Now, let's plug in x equals 2. We're going to get 3 over 2 squared plus 2, which is equal to 3 over 4 plus 2, which is equal to 2 3/4. Alright, so that's going to be our answer. So this is just a little bit of a review of all of our exponent rules. Okay. Remember, if you're multiplying two things together that have the same base, you're going to add the exponents together. Now, if you are dividing, so if it's x to the a over x to the b, this is going to be equal to x to the a minus the b, minus b. If you have it in the parentheses, then you're going to take everything in here and multiply it by the exponent. So x to the a to the b power is going to be x to the a times b. Now, if you had 7x to the a power to the b, this is going to be equal to 7 to the b power times x to the a times b power. Remember, this 7 here is kind of the same as saying 7 to the first power. So you're still doing the powers. You're still multiplying those powers together. So now it's just 1 times b. All right, rewrite each expression in its simplest exponential form. So we have x to the 5th over 2. We're going to subtract those, right? So it's x to the 5th minus 2, which is x to the 3rd. Here we're going to do the same thing. So it's 3, 10 minus 5, which is equal to 3 to the 5th. Now, I'm just going to flip this one. I'm going to do something here. So let's say instead we had x squared over x to the 8th. So this is going to equal x to the 2 minus 8, which is equal to x to the negative 6th, right? So then our final answer would be 1 over x to the 6th. And it looks like that's what we got down into here. So again, if we had 2 to the 4th over 2 to the 4th, this would be 2 to the 4 minus 4, which is equal to 2 to the 0, which is equal to 1. Now, you can go through all of the steps, but really you should look at this and recognize, hey, these are the exact same numbers, right? And when we have the exact same number on the top and the bottom, in this case, if you multiplied it out, just to keep it simple, multiply it out, you'd get 16 over 16. We know that's always going to be equal to 1. Here you would do x to the 2 minus 7, which is equal to x to the negative 5th. So it's going to be 1 over x to the 5th. It's going to be 5 to the 6 minus 10, which is equal to 5 to the negative 4. You get 1 over 5 to the 4th. Alright. So consider the exponential function 16 2 to the x. Find each of the following without using your calculator. So, relatively easy. If we basically every time we see this, remember we're plugging whatever values in the parentheses in for the x there. So this is the same as saying x is equal to 0. So here we would have 16 times 2 to the 0th power, which is equal to just 16, right? 16 times 1. If we plug 2 in for here, we would have 16 times 2 to the 2nd power, 16 times 4, 64. If we plug negative 2, we would have 16 times 2 to the negative 2, which is going to be 16 times 1 over 2 squared, which is equal to 16 times 1 over 4, which is going to be 16 over 4, which is equal to 4. Alright, I'm just going to do a few more of these with you guys, and that's it. But whenever, a lot of you, the questions you'll have is just to rewrite each of the following expressions without the 0 or the negative exponent. So when you're simplifying these, you're not always looking for an answer, though some of these will give you it, but you want to get rid of, I'm not always going to ask you to actually multiply it out by the exponent. If it's small enough, sure, you can do it. But otherwise, all I really care about is that there's no negatives and there's no zeros. So 5 to the negative 3rd could be rewritten as 1 over 5 to the 3rd. 6 to the 0 is just going to be 1. 2 to the negative fifth is going to be 1 over 2 to the fifth. 4 times x to the 0, that's going to be the same as 4 times 1, which is just going to be 4. Now, 4x to the 0 power means that you're taking everything in here to the 0 power, which is just going to be 1. Here you have x to the negative second, y to the fourth. Then x to the negative second is going to go down to the bottom, so you're going to have y to the fourth over x to the second. Now, we haven't addressed this in here, but let's say that I had an equation that was something like y to the negative fifth, z to the third over 4x to the negative sixth. Alright. Here, we would want to simplify this. We're going to move put it in red. We're going to move the y down, and we're going to move the x up. So then it's going to become x to the sixth, z to the third, over 4y to the fifth. All right. Now, what about if we had something along the lines of x to the fifth, y to the negative fourth, z to the third, over 3 x to the negative third, y to the negative second, z to the second. All right. So what I like to do here is just get everything on the right side of the fraction line, right? So the only ones we're moving, we're going to move the y, this x, and this y. So I'm going to rewrite this, and it's going to be x to the fifth times x to the third, y to the second, z to the third, over 3 y to the fourth. I don't know why I drew a z like that. Z to the second. And now, well, we can combine the x's there, so then it becomes x to the eighth. Well, from here we could use all of our exponential rules and just figure out what it is. So we would have x to the eighth on top. We would do y squared minus y to the fourth, and we would have a negative 2, so then it's going to become y squared on the bottom. Then 3 minus 2 gives us a z on top. And this will be our final answer. Alright, well, I hope those extra examples helped you guys out. If you guys have any questions, I'm always free during class to talk about it. You could always shoot me an email, whatever helps you guys out. And ultimately, I just want you guys to fully understand, everything that we're doing here. So I know this might be easy to some. Some of you guys might need the extra little bit of guidance here. It's always okay. You could always ask questions. You could always reach out for more examples. I'm more than happy to provide them for you guys. I'll see you tomorrow in class.